And tell me if you can hear me. So can you hear me now? Okay, then I have to repeat what I said. Okay, let me repeat what I said. So basically, we are looking at the substitution and income effects of a price change. So basically, we said that when the price reduces or increases, so basically the one commodity becomes cheaper and the other commodity becomes expensive. So the individual would substitute, say, the expensive commodity for the cheaper commodity. And that occurs along the same indifference curve. Like in this diagram here, along the indifference curve, the individual is substituting X for Y. So basically at A, he's able to consume 2 units of X, but because now X is cheaper, he increases the consumption of X and reduces the consumption of Y. So basically that is along the same indifference curve. Now, what actually happens is that at A, when the price falls, the budget line rotates outwards. When it rotates outwards, the individual moves to a higher indifference curve. So he's at point C1. Okay, it can be at any point along that budget line. So we are first considering point C1. Then later on, we shall see what if he's at point C2, what if he is at point C3. So at C1, the individual moves at C1. So the movement from A to C1 is what we call the total price effect. It is the effect of a price change. Because now X is cheaper, so he can increase the consumption of X from X2 to, let's say, X5. These are just examples. So he increases the consumption of X by, those are 3 units, let's say, from X2 to X5. But now these 3 units, some of them are due to the substitution effect, and some of them are due to the income effect. So the total price effect has the substitution effect and the income effect. It is composed of those two. Now we want, first of all, to isolate the substitution effect from the income effect. So we said that substitution occurs along the same indifference curve. So at C, C is on a higher indifference curve. So what we want to do is to force the individual back to the original indifference curve. So what caused him to move to a higher indifference curve is the higher purchasing power. So it is as if real income has increased. So when real income increases, he moves to a higher indifference curve. Now, when you want to take him back to the original indifference curve, then that means you have to take away the increase in the real income. So basically, what we do when you do that, you shift this budget line graphically. That's how you do it, to show that the income is taken away. The budget line will shift downwards until it is tangent to the original indifference curve. So that happens at point B. At point B, the individual consumes 4 units of X. So the movement from A to B is the substitution effect. So it is along the same indifference curve. So at B, when you give him back his income, obviously he moves to a higher indifference curve and he will be at C1. So the movement from B to C1 is the income effect. So that's why we are saying the total price effect is composed of the income effect and the income effect and the substitution effect. In other words, if we explain it in terms of units consumed here, So when the price reduces, he increases consumption by 3 units. 2 of those are due to the substitution effect because he's increasing from 2 to 4 units. 2 units are due to the substitution effect, and 1 unit is due to the income effect, so that the total price effect is 3 units in terms of that. Now, the position of C will depend on the nature of the commodity. So, first of all, because the nature of the commodity will also determine the signs of this substitution income effect and the total price effect. Normally, for any commodity, the substitution effect is positive. When I say positive, we are looking at a decrease in price. So when the price reduces, the amount will increase. That's why I'm talking of positive. Okay, so the substitution effect is, it can even be zero. Zero in that the individual may opt not to substitute the cheaper commodity for the expensive commodity, in which way the substitution effect can be zero. So it can only be zero or positive for a price reduction. So basically, when we talk of a normal good, the individual will settle at C1. Just okay, so basically at C1, the individual is okay, the commodity is a normal good. Because for a normal good, when the price reduces, the individual increases the consumption. So the total price effect is positive. That's why I said he, like for instance, in our example, he increases the consumption from 2 units to 5 units. Now, for the income effect, for a normal good, still it is positive. When you give him back his income, he will increase the consumption. And also the substitution effect is positive. So all the signs are positive for a normal good. Then when we talk of an inferior good, we say that for all goods, the substitution effect is positive. So still the substitution effect will be AB. But now this time, he will settle at CT. In other words, our indifference curve will touch that budget line at C2. So the indifference curve would be here at C2. Now at C2, when we analyze the signs, the substitution effect is positive, but the income effect is negative. Because at B, when you give him his income, he settles at C, because for an inferior good, the demand falls when the income increases. So at B, when you give him back his income, instead of increasing the consumption of that commodity, he will reduce the consumption at C. So the income effect is negative. So when position C is between A and B, then that is for an inferior good. And position C may be to the left of A. And this will be for a given good, because you see the total price effect is SC3. That means when the price of this commodity falls, the individual reduces the consumption. The individual reduces the consumption. So basically, that means and that happens for a given good. We know that given goods, the price and quantity demanded move in the same direction, but these given goods are also inferior goods. So basically, that means the income effect will also be negative. So the substitution effect is positive for an inferior good, but when you give him back his income, he reduces the consumption because it is an inferior good, and also the total price effect. In other words, the negative income effect outweighs the positive substitution effect, so that the total price effect is also negative. So for a given good, hope we know what given goods are. So basically, given goods, we know that the quantity or the quantity demanded will move in the same direction as the price. But on the other hand, they are inferior goods. So there is this saying, given goods are inferior goods, but not all inferior goods are given. So basically, that is the explanation. So here, this explains those. It depends on the nature of the commodity. And I think I have a detailed notes for this in the notes I told you about. The explanation is more for these signs of inferior goods, but I just hope, and if we meet again physically, I'll be able to explain this further so that you understand. Then we want to look at the demand relationships among goods. So when we looked at the substitution and income effects, we looked at how a change in the price of X affected the quantity of X bought when the price of Y is held constant. But now we want to look at a situation where a change in the price of, say, X could affect the quantity of Y, like that. So for instance, here the example I've given is that if our commodity X is miles that an individual drives, then this quantity is expected to decline when the price of fuel rises. So X is affected by the price of Y, or to increase when the bus fares increase. Like for instance, if, of course here we use so much these taxis, when the fares for taxis increase, then obviously you want to use your vehicle. So that means the miles you drive will increase. So basically, that is the explanation. We can explain them. So they are called the cross price effects, the cross price effects. Now this time we used the price of Y falling. So that now our indifference curve will change, because some people will think that it is only the price of X changing. So now let's see what happens when the price of it depends on the nature of the commodity, because we have what we call complements and substitutes. So basically, in the first panel, when you look at this panel, first of all, you look at these indifference curves. When you look at the indifference curves in panel A and panel B, they are not the same. They don't look the same. So in panel A, when you can observe closely, you can see that these indifference curves are L-shaped. They are almost L-shaped. And in this panel B, the indifference curve are more flat. They are flat. So when the indifference curve is L-shaped, it means that the substitution effect is very small. And when the indifference curve is flat, it means the substitution effect is larger. Like for instance, if we go back a little, if we go back a bit, you can see now. You just imagine this indifference curve. If it were L-shaped, this substitution effect will be smaller. Okay, now we go back to our diagram. So in panel A, we have the original position here, the individual buying YO and XO. Now the price of Y falls and the budget line rotates. When the budget line rotates, you can see that the quantity of X is increasing and the quantity of Y is increasing, because now that can be explained by that small substitution effect. So basically, because the substitution effect is fairly small, that means a fall in the price of Y does not induce a very large move along the indifference curve. So that means the quantity of X will drop little as a result of the substitution effect. Because we expect that when the price of Y falls, the individual is going to substitute X for Y, because now X is expensive than Y. So it would be that he's going to increase the consumption of Y and reduce the consumption of X. But because the substitution effect is small, that means the fall in X is small, is relatively small as a result of the substitution effect. Now, to know the final impact, we have to look at the income effect. So the income effect reflects a greater purchasing power now available, because we know that when the price of a commodity falls, the purchasing power increases. And when the purchasing power increases, then the individual can increase the quantity of the commodity bought. So basically, because now the total quantity of X bought will increase because of the income effect, the increase in the purchasing power available. So X will increase, and of course, Y is increasing. So you can see X is increasing despite the fact that the price of Y reduced. So both X and Y are increasing, and so you can see X and PY move in opposite direction, because the price of Y was falling, but we are looking at X increasing. So that is in that panel. But now when you see panel B, you can see that originally the individual is consuming XOYO. And when the price of Y falls, now you see the substitution effect is greater. So because it is greater, it will outweigh the positive income effect, so that eventually we have X reducing, but Y of course is increasing. These are for substitutes. And we know that anyway for substitutes, when the price of the substitute falls, then obviously there will be a reduction in the quantity. So in this case, X and PY move in the same direction. When the price of Y falls, also X falls. And this can be explained here. So indifference curves are relatively flat, implying a large substitution effect. So X declines sharply as Y is substituted for X. So this increased purchasing power causes more X to be bought, but because the substitution effect dominates, X will decline. So basically, that is the effect, the cross price effects. Now we want to look at the compensated demand curve, or the Hicksian demand curve. By the way, when you have a question, it's better you put up your hand, because I don't want to read the charts. Since so many people write different things, I don't want to, they distract me, okay? So if you have a question, it's better you put up your hand and I see it, okay? But if it can wait until the end of the lecture, then you wait until the end of the lecture. But if it is urgent, then you put up your hand. If you just put in the chat, I may not be able to read the chat, okay? Okay, so basically we want to look at the compensated demand curve, also called the Hicksian demand curve. Hicksian got from the person John Hicks, who came up with this idea. So basically, this compensated demand curve, because earlier on we looked at the Marshallian demand curve. Of course, also the name is from the individual Marshall. So it shows the relationship between the price of a good and the quantity demanded, on the assumption that other prices and utility are held constant. Now you see from that substitution effect and whatever, we said that the substitution effect is along the utility curve, along the indifference curve. So it means that along the indifference curve, utility is held constant. So the moment you say utility is held constant, then you know that we are on the same indifference curve. So here we assume that the individual is on the same indifference curve. So we want to see the relationship between the price of a good and the quantity demanded on the assumption that the prices of other commodities and utility are held constant. So this curve illustrates only substitution effect. Mathematically, it is written like that. So this compensated demand curve, I'm using HX instead of DX. HX is the compensated. When I said DX, that is the Marshallian demand curve. So the compensated demand curve is a function of the prices and the utility. Whereas we saw that with the Marshallian demand curve, it will be a function of the prices and the income. So basically here, this shows utility, and you see a bar on top of U, meaning that utility is constant. So it means individual's income is compensated so as to keep utility constant. Alternatively, the individual's real income is held constant as price of X reduces. So let's look at the function, compensated demand function. So this corresponds to a fixed level of utility. We know we have said utility is fixed. So we obtain it by minimizing the consumer's expenditures on the commodities subject to the constraint that utility is fixed. Remember, I told you whatever is given as fixed is the constraint. Now this time the utility is given as fixed, so it is the constraint. So whatever we do, it is subject to the constraint that utility is fixed. So now this is how we get our demand curve. So originally the individual is at point A on that indifference curve, buying X1. And when we plot it down in the down diagram, so we say at a particular price P1, the quantity bought is X1. Now when the price falls to P2, up here, the budget line rotates outwards. And the individual moves to point C here. This is point C. At point C, he is able to consume more units of X, that is X3. When you record that down in the down diagram, you have that point here. At price P2, the individual settles here. Now, when you join this point here, where you see my cursor, then and the initial point, I don't know if, let me see, if I can name that. If we call this A prime, if I call that A prime, that point A prime, and then I call this one C prime. Let me call this one B prime. Okay, so basically that is our diagram. So when you combine A prime and C prime, you get the Marshallian demand curve. That's the one I call DX. So that is DX. Now, we go back to the upper diagram. So we are at point C here. When we carry out a compensating variation, like we said, the individual moves to the original indifference curve. Remember, point C is not on this initial indifference curve. It is on a higher indifference curve. So the individual moves to point B. Now, when we recorded that in the down diagram, we have this point B prime, and the individual is consuming X2. Of course, you can see X2 is less than X3 because here you have compensated. You have carried out a compensating variation in income. So he consumes less. At the lower price P2, the individual consumes X2. Now, when you join A prime and B prime, you get what we call the compensated demand curve. So that's the difference. You can see the compensated demand curve is steeper than the Marshallian demand curve because compensated demand curve only has a substitution effect. It does not have income effect. Okay, Ronald. Ronald.
Yes, madam. Good morning to you.
Morning.
Yeah, you have said that when you join the A prime to B prime, you get the compensated demand curve. What about when you join A prime to C prime?
The Marshallian demand curve. That is
Oh,
the
thank you, madam.
Yeah. Muzei.
Yes, madam. Can you hear me?
Yes.
Yes, madam. Madam, I beg you repeat that kind of drawing once, those curves once.
What about Lumumba?
Thank you, madam. My inquiry is about it now for the Marshallian curve. Does it mean that the utility is not constant? And then two, is for the Marshallian curve, does it mean that all the effects apply? For example, the substitution effect and the income effect. Thank you very much, madam.
Okay, so basically, maybe I start with Lumumba. Lumumba, I'm saying that the Marshallian demand curve has both substitution and income effect because it shows the price effect. You know, I think in your first year, you looked at how to derive a demand curve, and it is derived from the price consumption curve. So the price consumption curve is derived from different, when the budget line rotates, when the price falls further, the budget line rotates. So it includes both the substitution and income effect. So that is the movement from A to C here. Even when you recorded that in the down diagram by joining A prime and C prime, that is the Marshallian demand curve. It has both the substitution and income effects. Now, so basically to understand this properly, you need to have understood the substitution and income effects. Like I said that at A, if the price of X reduces, of course, like originally we have P1. Now, when the price reduces to P2, so that means in the upper diagram, the budget line rotates outwards. So the individual moves to point C. So at each point, you record what happens in the quantity in both the upper diagram and the lower diagram. So that's why we are having A prime and the C prime when the price reduces. So when he moves to point C, of course, point C is on a higher indifference curve. You know, sometimes when you are drawing this, someone may see as if point C is on this indifference curve, but it's on a higher indifference curve. So at C, when you carry out a compensating variation, I told you compensating variation is taking away that increase in real income. Remember, the nominal income is fixed, but when you take away the increase in real income, you are doing a compensating variation. You want to assume that this individual is not better off. So you want him to go back to the original welfare level. That is the original utility or original indifference curve. So when you do that, the budget line shifts downwards until it is tangent to the original indifference curve. And that puts the individual at point B. So the movement from A to B here is the substitution effect. When you record that in the down diagram, he has X2 instead of X3. So you see, when you take away, obviously, it means that he's going to consume less of the commodity. So when you join A prime and B prime here, you get the compensated demand curve. And when you join A prime and C prime, you get the Marshallian demand curve. I think that is clear for now. When we meet, you ask me again. Let's try to derive it, the compensated demand function. So we have our expenditure and the utility. And now utility is constant. Remember, we said the relativity is constant. That's why I put a bar on top of the U to show that it is constant. So it is our constraint. And I said that normally we rewrite the constraint in this form, like you put everything on one side. When you write the constraint in that form, then you multiply it by the multiplier, introducing the multiplier. So that is our function Z. We form a composite function by adding this expenditure to the utility, which is a constraint. So that is our Z. And the maximization is achieved when the partial derivatives of Z are set to 0. So the Z dx, here we have Px, because here it is a 0. When we go to this side, we have lambda du dx, because here we have x and y. Of course, here u bar, there is no x, so assume it is a 0. When you go this side, you have du dx. The same applies to the z dy. So at first you have, this is 0, this is py minus lambda du dy. When you find the z the lambda here, because this one will be a 0, then you go here. So we have u minus uxy, that is our equation 3. So we go ahead and find the equilibrium, which is still given by the same equation. So still equilibrium is where the slope of the demand curve is equal to the slope of the indifference curve. That is our equation 4. So remember, we said when you want to derive the demand function, you use equation 4 and equation 3. You substitute equation 4 into equation 3 here, the dz the lambda function or equation. So basically, when you substitute them, you get this compensated demand function. But of course, we can use a particular utility function, because there you can understand. So assuming we have our utility, and it is x times y, and it is fixed. So you substitute that into this. Eventually, our equation 3 is that. That is our, but you equate it to 0. I forgot to equate it to 0, but you can do that. I think I cannot change it now. But you can, you know that this is equated also to 0, because we equate each of them to 0. So when we go here, from here we move to here. Actually, let me put it, I think now I can insert, no, not that one. I think I can insert the arrow. Okay, so from there, we go to here. So we have Px is equal to lambda y from this equation 1. Maybe the arrow can change a bit. Okay, so Px is equal to lambda y, and Py will equal to lambda x. So Px over Py is equal to xy. That is our equation 4. So you can cross multiply and you have this one. But see, we know we want to substitute this equation 4 into equation 3. So we manipulate it further. So because here, you see here, there's no Px, Py, there's no Px. So what you do, you make y and x the subject. So when you make y the subject, you have this. And when you make x the subject, you have that. Then from that, you go here. You know, when I don't put these arrows, I wanted everything to be on this slide so that you follow. So from here, you substitute these into your function here, equation 3. So when you say u, I forgot to put a bar here, but you know it is there, minus x into y. Now the whole of this is y from this equation. The whole of this is y. So it becomes u minus px x squared, because we have this x here and that x here. So px x squared over py equal to 0. Then you go here. When you go here, then this one becomes, of course, you want to multiply each side by py. So you say pyu minus pxx squared. Then you can say it is equal, because you can take this side and say pyu over px will equal to x squared when you take this the other side. So x is the square root of that. You do the same for y and you find y. So that is, these are the compensated demand functions. And they're different from the Marshallian, because Marshallian, it will be b over 2px or b over 2py. So these are the compensated. Now, when you are given a utility function and the prices and the income, and you are told to find a compensated demand function, you get a wrong answer if you don't make utility constant. Because if you make the budget constant, it means that you'll be getting the Marshallian demand curve, and you'll get a 0 for that. So for a Marshallian demand curve, you make the budget constant. And for a compensated demand curve, you make utility constant. And you know the implications, because eventually you'll be multiplying the multiplier, the lambda, into the constraint. So that's where the difference comes from. Now, in your free time, you read about the advantages of indifference curve analysis over the cardinal utility approach. And you also read about the limitations of the indifference curve analysis. Now, any question before we continue? Yes, Lumumba. Yes, Lumumba, do you want to ask?
Yes, madam.
Yes.
I'm asking. Told us for the Hickshian demand curve, like for the composite demand curve, utility is constant. And then for the Marshallian, the budget, it's the budget that's constant. What do you mean by?
Yeah? I haven't heard the question. What do I mean by what? Remember, I haven't heard your question, please. Lumumba, ask your question. I haven't heard it. Okay, maybe he will. Okay, to me, listen to Simon. Simon, ask the question. You tell Lumumba that I haven't heard.
Good morning, madam.
Morning.
So my question has been about, because you've been talking about the function, the utility functions. But then I've been kindly requesting that you like repeat from I think slide 10. Then you've been talking about when we should consider it constant and when not to consider it constant.
Okay. Okay, let me answer that. Normally, okay, I know this may confuse you for some time, okay? So let me first answer Simon. So basically, what's here, when I talk of functions, constant, whatever, now this is what I want you to get. Under the Marshallian demand curve, the usual demand curve we know, we know that we assume that the budget is constant, because in the assumptions, we say that the consumer's income is constant. Do you get that? So basically, when something is given as constant, then it is a constraint. It is the constraint. Whatever you do, you have to do within that. You cannot change the budget. So in that case, it is the constraint. So we normally multiply the lambda. Lambda, I said, is the Lagrangian multiplier. We multiply the lambda into the constraint, whatever is given as a constraint. So if someone is talking about the compensated demand function, what should come in your mind is that with the compensated demand function, the utility is constant because it is assumed fixed. And then you should know that what you have to do is to multiply the multiplier into that constraint, which is the utility. So when you follow that, whatever you get will be the compensated demand function. If you make the budget constant so that you multiply the multiplier by that constraint, by the budget, then when you follow through, what you get will be the Marshallian demand function. Hope I've explained the differences. Now let me listen to Angela. Angela. Nakalema Angela.
Yes, madam, as inquiring about the constant, the budget being constant, but you have answered it.
Okay. Makerere. Makerere, do you want to answer anything or to ask? Okay, Mutunji. Mutunji.
Madam. Yes, madam.
Mm-hmm.
I was requesting that if at all you have the detailed notes in soft copy, you could share with us, because for now, some of us cannot be able to access the university premises.
So, you know, these people, there's a way they compiled this in the soft copy. I don't have them. There is a way these people compiled their notes. Those people I told you they are selling. And I don't know if I have compiled notes in soft copy. Okay, let Lumumba, I didn't hear your question. I don't know if I can hear it.
Yeah, thank you, madam. Like I was requesting whether you would show us.
You lost again.
Yeah, like are you getting, madam?
Now I can hear you. You talk and you talk. So what do you want?
Like I was inquiring that, like you try elaborate showing me the utility being constant on the graph, like what you're trying to mean by saying the utility is constant. Thank
Along
you.
the difference curve.
Yes, madam.
Mm-hmm. So that's what
Like,
you want in the graph. You want to
yes,
see
madam.
it is constant.
Yes.
Okay. Colin, ask. Colin, do you want to ask? Okay. When I say utility is constant, first of all, when you look at the properties of indifference curves, okay, then the definition of indifference curve, we say that this is the locus of commodity combinations which give the consumer the same level of utility. So that means along the indifference curve, utility is constant, it is the same. The individual is indifferent as to whatever combination he consumes. So along the indifference curve, utility is constant. So basically, if the individual is along the same indifference curve, just know that the utility is constant along that. He gets the same satisfaction, because I may be consuming 3 apples and 2 mangoes, and then I'm satisfied in the same way I would consume 3 mangoes and 2 apples. So along the indifference curve, utility is constant. I don't know if that was the question Lumumba was asking, but how we get back to this in maybe the whole thing, I don't know, because just when the price reduces, the individual obviously moves to a higher indifference curve because the purchasing power increases. He's better off than before a price reduction. So when he is on a higher indifference curve, what we do, if we want to bring him back to the original indifference curve, we take away that increase in the real income. I'm talking of real income because, in other words, with the same nominal income, he can buy a larger basket of goods. So that is real income, change in real income. When you take it away, you force him back to the original indifference curve. So basically, that's how you show the substitution effect. So at B, he's back on the original indifference curve, and the movement from A to B is the substitution effect. Colin Mugweri, do you have a question?
Yes, when I'm coming up with the composite function, that's Z equals PXY plus PYY. When with the multiplier out of the bracket, what I'm not getting is that constant utility minus that utility into XY. Why do we have to subtract that utility into XY from the constant utility?
Okay, so this is the utility. Remember, it is the same thing as we said that, let me see if I can insert something here. Because, like, for instance, if let me first write the other one and see. So if you have that, remember we said if we had that, B equals PXX plus PYY. Now, if you want to put everything on one side, you say B minus PXX minus PYY. So now it will become, oh, sorry, it is a minus, not a plus here. So now it will be B minus PXX minus PY1 if we are dealing with the other function, the Marshallian. So you put everything on one side. The same applies to this. So this one, I put a 0 here, but it's not supposed to be here. So you see it is U will equal to UXY. In other words, you say utility is a function of two commodities, X and Y. So that is our utility. So that's why if we put everything on one side, I say U minus UXYY. And that's what I am multiplied by the lambda. Does that answer the question? Hope that answers. So basically, that's how we do that. Like we are saying that you look at the constraint, you rewrite it in such a way that everything is on one side, and then you multiply it by the multiplier. So who is this Putin? I hope you don't have his character. Unmute yourself and ask a question. Or you wanted us to see that there is a Putin in Uganda. You don't have a question. Okay, so I don't know if that has answered your question, Colin. Is it Colin or whatever? Any other question? Okay, if there's no question, I think we can stop here, so that those who want to go, they can go. Have a nice day.